Hello, this is Dr. Eidelberg, and our presentation today is definition of robot positions related to offline programming of robotic actions. We start with looking at the programming steps. The good idea to name the robotic process that we're working on such that the colleagues that work with us will know what is it that we do. Then sketching the motion diagram of the robot and defining the robot position numbers. The third step is to set up the processing on a software called Cell Setup. We then download the processing from Cell Setup to another program called RoboCell, where we write the program. The next step will be teaching the robot its pick and place and approach positions, writing the process program and simulating the program. The way we describe what the robot does is using a few words such as palletizing cartons on pallets, or welding bicycle frames on fixtures, or load-unload crankshafts to CNC machine tool. But what we're doing here is pick and place of boxes on a conveyor belt. The first word is a verb, which describes the robot action. It hints the end of arm tool that the robot is carrying to do the job. And then we name the object of the robot, which hints us the material and the size of the process. And finally, we name the peripheral equipment, which also hints the environment. For example, painting car body parts in a paint chamber is indicating a large size part, or palletizing cartons on pallets is the smallest size, and drilling PC boards on a chalk is even smaller. To see some examples, we have some pictures set up here. Here's an example of a robot painting a car in a paint chamber. Here's an example of a robot palletizing boxes on pallets. In this picture, we see a robot welding a frame over here, bracket, on a workbench. This example shows sorting process of a colored box which move on conveyor belts and being sorted over here. This shows us a wing of a wind turbine that is being drilled by the robot. And finally, we see here a robot which loads and unloads parts into a machine tool. In our process, we pick and place boxes on a conveyor belt. We see here the robot. We see the part, we see the conveyor, and there's also a sensor. And now we need to define the points where the robot will have to come in and do the pick and place. The part is located on a table, so we define that position as position 1. The second point where the part is being placed is position 2. And the third point is where the robot picks the part from the conveyor. It's position 3. The robot comes in from its park position, which is defined as point 99. It comes to position 2-1. It's an error here. This position should be position 2-1. And then it comes down to its pick position 1-1. It goes back to the approach position 2-1, and then from there it goes to the approach position of point 2, come down to the place position point 2 at the lower elevation, comes back up, then goes to the park position, coming back to pick the part in position 2, 3, and then picking it up in position 1, 3, back to 2, 3, and then to any other place where we want to place the part. The way to describe that process is using a motion diagram. We have front view here, we have top view here. All the points are shown on the same location, whether it's lower elevation or high elevation. So this elevation is elevation 1. So all the points in this elevation start with the number 1. This is the line for point 2. So all the points on this line will end up with the number 2. So this point is 1, 2. This point is 2, 2. This point is 1, 1. This point is 2, 1. This point is 99, where the robot park. This point is 1, 3. This point is 2, 3. So the diagram also shows us the process of the robot motion. The robot starts from 99, going to position 2, 1, elevation 2 and point 1. Then it comes down to pick up the part from 1, 1, goes back to the approach position of 1, which is 2, 1, then goes to position 2, 2, which is a post position of point 2, coming down to place the part at position 1, 2, going back to the approach position 2, 2, and then parking at position 99 while the conveyor is moving the part from place position to the pick position. Once the part is in its pick position, the sensor gives a signal to the robot to pick it up. The robot goes from position 99 to the approach position of point 3, come down to pick up the part at position 1, 3, then go back to the approach position 2, 3, and then go back to wherever else the part has to be placed. This completes our presentation of defining the robot position. And as an exercise, we like to ask the student to redraw this motion diagram and show the process as shown on this screen. Thank you.